All right, continuing on Friday. Got to see so many smiling faces this morning. Anybody else not here on Friday? We'll continue the notes from Friday. Hope everybody enjoyed their weekend, enjoyed the prom and all the festivities that went with the prom. We are very quickly closing out the school year here. But we still have school days, we still have things we have to cover, so you need to make sure that you continue to push and get yourself through this material. On Friday, we start talking about the idea of vectors. Victor, when we're talking about vectors, we're talking about directed segments. Segments are parts of lines. We're talking about a directed segment. Segments are parts of a line. When you have a segment, you have a beginning and you have two endpoints, a starting point and ending point, and a line in between, and you have a specific direction that you're going to be going. So when we're talking about vectors, Victor, you're looking at the idea of going a specific length in a specific direction. And as we talked about on Friday, giving ourselves directions from point A to point B to get to your house. This is directions to my house, but we went through some directions to your house, and those are all ideas of vectors. When you go a specific length in a specific direction. So we have a directed segment. You have to have an initial position, a tail. You have a terminal position, which is called the tip. We label them with a lowercase letter and a half arrow ray above it. Okay, and that's how we label vectors. We talked about the magnitude. Magnitude is the length of the vector. Huh? I don't know what that. You have magnitude of the vector, double absolute values. Sometimes you'll see a single absolute value. Scalar multiplier affects the magnitude, but not the direction. So we can double a length as we went with respect to 2A. A starts here, ends here. So we want to go that specific length in that specific direction. And as I talked about on Friday, what you could do with respect to dealing with the idea of a straight edge, because you should not be freehanding these. You can make yourself Mr. Wizard's straight edge, where you can measure a specific length and mark it on your paper, that specific length here, where A starts here and ends here. And you need to make sure we go in the direction, so I need to slide it down and I can draw my vector here, giving those 2 points, the end points there. So that's how you can handle that. If you have a straight edge, you can work with a straight edge, an actual ruler. I think those are 1.5 inches or close to them. When we dealt with 2A, that just means we have 2 of A. So we are doubling the length. And we have multiplication in there if you want to think of it that way. It is our coefficient to the vector. Once again, it's telling us just double the length. Well, when we deal with negative 3b, well, if I deal with 3b, if we deal with just 3b, that means we have three of the b's. Well, if we were just dealing with positive 3b, we would have 3 of the b's. This would be a positive 3b, going upwards to the right. We're just tripling the length of b. So we have positive 3b going upwards to the right. What do you think we do if we had a negative 3b? What should we do? Well, think about what the negative means. The negative in mathematics, yes, we say it's -3, or if we have -5 or -7, that we just call it a negative number. But another definition of that negative sign, it means it tells us to do the opposite. The opposite of whatever you're working with here. So if I have -3b, that is the opposite to 3b. Well, what would be the opposite to 3b? If we go upwards to the right for positive 3b, what's the opposite of that? Right. What's the opposite of going upwards to the right? Downwards to the left. So all we do with respect to a -3b is, rather than going upwards to the right, we take it downwards to the left. We just go the opposite direction. It does not affect the length of it. It just affects the direction. We go backwards. Now this whole first part deals with the introduction to vectors, but it also deals with operations of vectors. If we have a plus b, we want to show graphically what is the addition of a plus b. Well, when you gave directions to your house, you did vector addition. Because going to my house, we started here, we went down to the corner by Mrs. Ed's room. Wherever we stopped that one, we started the next one. I turned left and went out to the stop sign. I stopped that one, and then I went north along Mill Street out in front of the school, going in that direction. So wherever we stopped, we started our next one. Well, all that is vector addition. Victor? So what this is telling us to do is we want to travel A first. So if I travel A, I can start this anywhere I want. Like I started out here at the flagpole. Or we can start in front of the school parking lot. We can start directions to your house from anywhere. Well, I'm going to start at that spot. You just pick a spot and you can draw in vector A. This is my initial position. This is my terminal position. And the arrow, once again, tells us which direction that we are going. I'm starting here, and I'm going in this direction. So the arrow tells us, the half arrow tells us which way we're going. Well, we are stopping at this point. So we have traveled vector A. Victor? We now, wherever we stop our first one, we now must start our second one. So I need to now travel wherever I stop my first one. For the second one, this now turns into initial for vector B. Victor? So I'm traveling A first, I'm stopping A, and then I'm going to B. And I'm going to travel B, and now this is my terminal position. So once again, it's just like going to your house, directions to your house. Okay, you don't stop somewhere and then call up to the Starship Enterprise and say, beam me up, Scotty, and he beams you up to the Starship Enterprise and then beams you down somewhere else. You start one spot or one direction, then you continue to the next direction. But we have to take a look, what is meant by A plus B? Well, we just took some, if you took standardized math tests or ACT tests or whatever, and one of the problems on that test says 5 plus 4 equals. Gavin, what would you write down?
9.
9. Why is that?
5 plus 4 equals 9.
Yeah, because we would sit there and say 5 plus 4 is equal to 9. Okay, I think. Could you also write that? 5 plus 4 is equal to 5 plus 4. Yeah. But really what we want, when you're given the problem 5 plus 4, we want the results of 5 plus 4. Okay? So we can think in our mind, or we can pull out our calculator and add 5 plus 4 to give us a result. Well, if I ask you to take A plus B, and you leave it as A plus B as you've drawn there, what you have told me is 5 plus 4 is equal to 5 plus 4. What we want is we want a solution to A plus B, which is called a resultant vector, which I will symbolize B subscript R. This is the solution to your vector addition. What is the solution to the vector addition? Well, the question is how do I find the result of A plus B? Do I have to go back and deal with what I did with trig identities? Because I have no numbers there. I have no numbers. How do I find the result of A plus B? Well, what we get to do is take a stroll down memory lane to where you were wee little. And when you're wee little and your parents may have read you a book, one of the books, or maybe an elementary school teacher, might have read you a book and a story of Little Red Riding Hood. And we don't remember the story of Little Red Riding Hood. I will rekindle these thoughts, these fond memories into your brain. Little Red Riding Hood was la 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 la. She was going to Grandma's house. Okay, she was taking some goodies to Grandma's house. She had a basket of goodies. She was going to Grandma's house, and she was going to give to Grandma. Okay? And at some point, Little Red Riding Hood ran into who? Big Bad Wolf. The Big Bad Wolf. And Big Bad Wolf said, "Hey, Little Red Riding Hood, where are you going with all these goodies?" And Little Red Riding Hood said, "I'm going to Grandma's house. I'm going to take these goodies." So the Big Bad Wolf said, "Oh, Grandma's house. Oh, okay. You can go on your way then." Well, at that point, Little Red Riding Hood continued down her path, and she eventually got to Grandma's house. Well, what did the Big Bad Wolf do? Huh? Before that, how did he get what he do? He took the Shortcut, there we go, thank you very much. He took the shortcut to Grandma's house. So this was the big bad wolf, and this was Little Red Riding Hood. La 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 la. Big bad wolf took the shortcut to Grandma's house. He munched on Grandma. And then Little Red Riding Hood showed up, and you know the rest of the story, hopefully. Well, the reason why we talk about Little Red Riding Hood and Big Bad Wolf is, well, Little Red Riding Hood went la 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 to Grandma's house. Big Bad Wolf went the shortcut to Grandma's house. Well, the shortcut to Grandma's house is also called your resultant vector. Victor? You gave directions to your house step by step. And hopefully, those step-by-step instructions, you stayed on the roads. Hopefully you did. You just didn't turf anybody's yard. You stayed on the roads and did things that are legally correct in driving. But what if I told you there's going to be a helicopter out here by the flagpole? And you're able to get in that helicopter, lift straight up from the helicopter, and fly directly to your house. Now you don't have to go the roads, you can go directly to your house. And you don't have to worry about going through the roads. That is the resultant vector. Victor? We are still starting on this spot. We are still ending on this spot. So rather than go down the path of Little Red Riding Hood, as she went down this path and then to this path to Grandma's house, the big bad wolf, he went from this point right here and he ended up at this point right here. So he still started and ended at the exact same spot. This here is your resultant vector. Victor? This is the value of 9. If you don't draw that in, you're saying 5 plus 4 is equal to 5 plus 4. You're not giving me a result. So you need to show the resultant vector in there, Victor, to be able to get a correct solution. Well, what if we had A minus B? Well, what we learned early on in mathematics when we dealt with integers, when we have subtraction, A minus B is equal to A plus a negative B. So I could take the negative up with the B. So what we want to travel now is we still want to travel A first. So we're still going to travel A first. We're starting here and we're stopping here. But at this point, we're going to add in a negative B. Well, if I added in B, that's what we have here. But I want to go to negative B, so what do we have to do to B? Go downwards to the left again. So we have the exact same length here, but now we are going negative B. So here's A plus a negative B. And then once again, we need to draw in our resultant vector, Victor. A plus 2B. Okay, draw in your A. That's Friday. Nice. Draw in your A. Now we're adding in 2 of the B's. So this is our A. We start here. I travel A. Where I stop my A, I then start my B's. Now we need to go 2 of the B's in the positive direction. So we're not changing the direction here. So draw in your 2 B's. So you have 2 of your B's. There's my 1B. There's my 2B. Or you can just look at my length and go 2 of them. Double it. So we have 2B here, or not B. And then once again, draw in your resultant. Once again, resultant is the shortcut to grandma's house. Okay? There's a little red writing here, little red writing here, la 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 la. And then we have big bad bump, shortcut to grandma's house. So here is your resultant vector. 3A minus 2B. Okay, whenever I see a minus in there, my suggestion to you is change that into plus and negative. Might want to space yourself out a little bit here because we have 3 of the A's. So draw 3 of your A's. So there's your 3 A's. Then we have minus 2 of the B's. So rather than going upwards to the right, you're going downwards to the left. So you draw in 2 of your B's downwards to the left. Once again, I'm keeping the same length of B, but I just have 2 of them there. And I go in the opposite direction. And then draw in your resultant vector. Now, common mistakes that occur with this is we don't put the arrow in with the resultant vector, or we complete the triangle and we go in the opposite direction. Remember, when we draw in the resultant vector, we are just taking the shortcut to grandma's house. So we are still starting here and we are ending here. This is terminal, this is initial. So we are still starting at my initial, and we're ending at our terminal, so we're still going down here. So you have, bless you, you have a double arrow down here at the end. Okay, common mistake, once again, is put this arrow up top, but what that would look like with respect to vectors is I'm going here, then back to here. I'm starting where I'm stopping where I'm starting at. We want to be able to start at the same position and end up at the same position. Questions? The first part of dealing with vectors, is dealing with just drawing these in. if you have a different color ink pen or whatever that you can utilize for your resultant, sometimes people will utilize that. If you don't, it's not mandatory. But if you want to get fancy schmancy. All right. Solutions are posted for you. What we will do is today just practice drawing the vectors, drawing vector addition. Tomorrow when we come in, we'll start throwing numbers in there. And when we start throwing numbers in here, we are creating triangles. And when we create triangles, we will go back and look at law of sines and law of cosines and apply law of sines and cosines to the triangles now. But we have to first understand what we mean by dealing with just vectors and drawing the vectors in and getting resultants in. All right, questions? You have about 15 minutes here to be able to get some of these done on the front side.